following scatter plots, which is true about their correlation. None are zero, so this one's zero, this one's zero. Correlation means how strong is their linear situation. Let's see. This correlation is zero because there's no linear relationship here. This one's zero also, and this one's pretty linear right here, and it's going down in a negative fashion. So I'm going to say it's this one, choice E. So two are zero, and the other one is close to -1. It's not quite -1. It's close to -1. So that'd be choice E. Okay. So chapter 9 review. Let's go ahead and get started. So a sampling distribution. Inference is drawing conclusions about a population based on results from a well-chosen sample. In other words, we use sample statistics to estimate population parameters. So note that the different samples yields different values of statistics. Bias and variability are two important concepts related to a given statistics. In order for a statistic to be an unbiased estimator of a population parameter, the mean of the sampling distribution must equal the true parameter, which is your true mean, and it's usually unknown. So the variability of a statistic is controlled by the sample size. Larger samples get better estimates. So larger samples makes your standard deviation decrease also. So let's do some sampling proportions here. So sampling proportions for p hat. So p hat is an unbiased estimator. It's our sample proportion, p hat. So this is our sample proportion is an unbiased estimator of your population proportion. That's what this is, population proportion. Since the mean of my sample parameters equals my population parameter. This is my mean of my sample parameters, and this is my population parameter. Okay, so if you're talking about proportions, you guys, then our sampling standard deviation is this formula right here. So this is my sampling standard deviation is the square root of the population proportion times 1 minus that divided by the square root, and it's all underneath the square root, divided by your sample size, okay? Provided that 10 times your sample size is still less than your population size. So this n is your population size. I had a student ask me if that means normal. In this case right here, it's my population size, okay? So the shape of the sampling distribution is approximately normal if n times p, this is my sample size, times my proportion is greater than or equal to 10, and n times 1 minus p is also greater than or equal to 10. Then the sampling distribution is approximately normal. Okay, so sample mean, so using the law of large numbers, boy, that was hard. So averages are less variable than individual observations, so you'll see why in just a second. So averages are more normal than individual observations, and the sample mean, which is x bar, has a normal distribution. And we write, and so when it asks you to describe the distribution, you say normal with the n right there, and this is my population mean, and then this is my sample standard deviation. So you take your population standard deviation divided by the square root of n. So by the central limit theorem, it says that it is true for any population as long as the sampling distribution n is large enough, and typically we want n to be greater than or equal to 20. Some books say, greater than or equal to 30. Some books say greater than or equal to 20, so it just depends, you guys. So the Wechsler Adult Intelligence Scale is a common IQ test for adults. The distribution of the WAIS scores for people over 16 years of age is approximately normal. So there's normal, where there's my mean of 100, and this is my standard deviation of 15. Okay. So what is the probability that a randomly chosen individual, that is singular individual, has a score of 95 or greater? Okay, so we're going to use our z-score, x minus the mean divided by the standard deviation. Now I use the population standard deviation because this is an individual. It's only divided by the square root of 1. So the square root of 1 is just 1, so I just use my population standard deviation if it's a single person. So this is my x that I'm looking for, so 95 minus the mean divided by the standard deviation, and I get negative 0.33333. Okay, and it says or higher, so when I do a bell-shaped curve, it's going to be or higher. So there's my z-score right there, the negative 0.3333 right there, right where my cursor is right there. Okay, so you look that up in the book, and your book gives you this value, 0.3707 in table A for your z-score table. But since it's greater than, we want this side over here, so we do 1 minus the book. So the probability would be almost 63%, so 0.6293. Okay, what's the probability that an average score of 60 people is 95 or bigger? Okay, so now this is going to change this number only, your standard deviation. So your standard deviation for the sample is going to be the population standard deviation divided by the square root of 60. Okay, so I get 1.9365. So that's what goes right here. Everything else is the same. So it's 95 minus 100 divided by this number right here. So I did that right here. This gives me my z-score of a negative 2.53. Okay, and then the negative 2.53 is way over here. It's farther to the left. I need about 3 more minutes on this video, ladies, okay? And then so your book gives you this side over here, but we want this side over here, so we will do 1 minus that, so it's 0.9951, okay? All right, I had some students come in. I'm almost done anyway. So suppose that 47% of adult women think that they do not get enough time for themselves. So an opinion poll interviewed 1,025 randomly chosen women and recorded the sample proportion who feel they don't get enough time for themselves. So describe the sampling distribution. Okay, so my sampling distribution is we think it's normal, and we got to get our sampling standard deviation. So our sampling standard deviation, now I use this formula because it said proportion. This is my proportion formula, so keyword is proportion. So there's my sampling standard deviation. Okay, so my answer is going to be it's normal with that mean and that standard deviation. That's how you describe that distribution right there. Okay, the truth about the population is your proportion is 0.47. In what range will the middle 95% of all sample results fall? Well, the 95% is within 2 standard deviations. So I take that standard deviation that we calculated, I multiply that by 2, so it's going to be that much below and that much above. So it's going to be that much below the 0.47, so I subtract that from 0.7 and then add it to 0.47. So the middle 95% will be between 0.4388 and 0.5012. Okay, and then number 3 says, what's the probability that the poll of the sample, which fewer than 45% say they do not get enough time for themselves? Okay, so we just plug that into our formula. Z equals x minus the mean divided by the standard deviation. We get that z-score. Okay, and then so it's saying fewer than, so fewer than would be to the left, so we look that up in the negative 1.28 in the z-score table and we get that. Okay, so there's the answer there. Easy enough. And then lastly, if you want to have some more resources, you can check that side out, and if you are in my class, I would assign that for your homework. Take care.